Hello students of the CCS Academy class 12 physics. This is your video number 9 and chapter number 1. Now I am going to tell you about the heading number 7, which will electric field lines and their examples. First I am going to tell you why I will study electric field lines. As I told you in the earlier video, electric field is due to the electrical influence of either the single charge or due to the system of charges at a particular point. But what is the need of electric field lines? That electrical influence represented geometrically by some curves or lines. So this is just the imaginary representation of electrical influence due to a point charge or due to the system of charges at a particular point. So this is the imaginary curves. What is the definition? I am going to tell you first, and then I will go in the detail of that. What is the meaning of each words of the statement present of the definition of electric field lines. Electric field lines are the imaginary curves. As I told you earlier, students, they are the imaginary curves, just are to show the electrical influence of the charge or system of charges at a particular point. ये सिर्फ imaginary curves है. The tangent at which at any point gives the direction of the electric field at that point. It means that if we have electric field lines, suppose in the figure 7a, you look there, this curve, look at this by my pen. Yes, this is the electric field lines represented by E. So this represents the electrical influence due to any system of charges which is not visible here. Okay, so this curves, I am going to tell you one more time. Look here, this as the outline of my pen. Yes, this is the electric field lines represented by E. Now come to at point P. What is the direction of electric field at that point? Draw the tangent. Okay, this is the tangent. This tangent will show you the electric field E1 at that point P. Now further, suppose at point Q, what is the direction of electric field? Look at the tangent here. This tangent gives the direction of electric field at that point. So by the figure, if you could understand, now I am going to read one more time because your concept would be clear after that. Electric field lines are the imaginary curves. Okay, imaginary curves, I told you earlier. The tangent at which, look at this, tangent at P gives the direction of electric field at that point. The tangent at Q gives the direction of electric field at that point. Okay, the tangent at which at any point gives the direction of electric field at that point. Okay, so by the use of this figure 7a, you guys can write the definition of electric field lines, which is a very important heading for examination point of view for your CBSE exam. Okay students, now further I am going to tell you more examples of electric field lines on your page number 12 and the same heading, electric field lines. Look here students, on page number 12, examples of electric field lines. Okay, this electric field lines are what? Example number 1, electric field due to a positive point charge. Look here, there's a positive point charge. Okay, what would be the direction of electric fields? First I'm going to tell you what is the figure is saying. Figure is saying radially outward, 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 means this arrow represents the direction of electric field lines or electric field at that point. Suppose I want to put test charge here. What will happen? Test charge is positive, Q is positive, they will repel. Definitely it will repel. The direction of test charge is same as the direction of electric field at that point. Again, this is electric field direction because radially outward, radially outward, radially outward. Okay, I'm going to read one more time students. Examples of electric field lines. Example 1 is what? Electric field due to positive point charge. Electric field lines are the radially outward in the example of point positive charge. Okay, there are further examples I am going to tell you. Now that is I am going to tell you on page number 13, and that is your example number 2. What is example number 2? Look student, I'm getting closer. Electric field lines due to negative point charge. Look, there is a negative point charge. If I will put test charge here, what will happen? Negative will attract positive test charge. So direction of test charge is same as the direction of electric field lines. I told you earlier so many times. So this is the direction of electric field lines. This time not radially outward, just was in the case of positive point charge where it was radially outward. Now if we go to the negative point charge, look here student, go to the negative point charge, it will come radially inwards, 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 inwards. The value, the electric field lines are radially inwards. This is your figure number 7b. Okay, I have discussed two examples. Now I'm going to the example number 3, students, and the page number 14 of your heading number 7, that is electric field lines and their examples. Now come to example number 3, electric field lines due to an electric dipole. Electric dipole is plus and minus charge separated by some distance. Okay, I will explain you the major aspect of electric dipole in my next heading, but before that, electric dipole for you student, just two equal and opposite charges. Electric means you know, dipoles matlab means two poles, plus q and minus q. Okay, plus q charge, when I will put test charge here, what will happen? Test charge is positive, repelled by this, and it will be same time attracted by the minus q charges. So the direction of test charge is same as the direction of electric field. So the electric field in between is the curve starting from plus and end at minus. Similarly here, starting from plus and end at minus, starting from plus and end at minus. But when you are here, look, there's a different scenario. What is the different scenario? If I will put test charge here, then test charge will be more closer to plus q. So the effect of plus q is more, and it is at a distant point from minus q charge. Look at minus q charge. Okay student, so there is less influence of this negative charge. Plus charge would repel, minus charge would attract, but the influence of plus q charge is more. That's why you can see it is radially outward. Okay students, so this is clear. Since it is closer to plus q charges, so that is outward, and when it is towards the closer to the negative charge, look here, attraction is more predominant, more dominant, more powerful when compared to the repulsion of plus q charge. So when we are closer to plus q charge in electric dipole, then the outward, and when you are closer to the negative charge, influence of attraction is more inward. So this figure 7c represents the example 3, electric field lines due to an electric dipole. Okay, figure 7c, the corresponding electric field lines due to an electric dipole is shown in figure 7c. Okay students, so these are the examples. Further, I am going to tell you about the properties of the electric field lines. So this is the very big heading, and I am telling you this is the one of the most important heading of this chapter, and also for the future reference for the great and deep concept of physics. Now come to the page number 15, that is properties of electric field lines. Okay students, what is the first property? I am going to read for you. The tangent at any point of electric field gives the direction of electric field at that point. It is the by definition you can see in figure 7c. Tangent gives the direction of electric field, tangent gives the direction of electric field. So by the use of this figure, which I have discussed earlier in the definition of electric field lines, you can say yes, this property is very clear. The tangent at any point of electric field gives the direction of electric field at that point. Figure 7c. Now second property, electric field lines never intersect each other. Okay, reason? Because at intersection point, look, suppose I want to explain this P2 by the help of the figure 7d. Look first 7d, and then I will come back to the property 2. Look, concentrate on this figure 7d. There is one electric field lines you can see in my pen, E1. There is another electric field lines you can see in my pen. Look at my pen. This is the outline. Okay, I'm going to dark it for you students. This is your E2. Okay, E1 electric field and E2 electric field. I intersected. Let's see what happens. At intersection point for electric field E1, the tangent is PT1, and for electric field lines E2, the tangent is P2. Is it possible for a test charge to go at the same time at two directions, PT1 and PT2? No, because electric field is not the multi-directional, it is only one direction. So this contradiction arises because we intersected. So we can say electric field lines can't intersect each other. Let's students, on the basis of this figure 7d, I am going to read it one more time. Electric field lines never intersect each other. Reason? Because at intersection point, two tangents can be drawn. Yes, can be drawn, PT1 and PT2. Okay students, I'm getting closer. Look at that. Yes. Drawn means two possible directions of electric field, which is contradiction. Which is contradiction. Hence, electric field lines can't intersect each other. So this is the property number 2. Now come to the next property, students, on your page number 17. That is property 3. Electric field lines can't have sudden breaks. Why can't have sudden breaks? For this, I am going to tell you about the figure first. 7E. Yes, 7E. Look at closer. This is electric field here at P, and further is here. There's a broken point. Look, there's no line. Okay, students, can you see? This electric field is here, and at point P it is broken, and further is electric field. So what is in between? There's no electric field, means it is the breaking point. At breaking point, there are two possible directions. Two, not multi, you can say. Many can be drawn. Is it possible for a test charge at a particular point can go simultaneously at various directions? No. So this sudden point can't exist. This means electric field lines can't have break point, can't have sudden break. On the basis of this clear figure 7E, students, we can understand property 3. Electric field lines can't have sudden breaks. Reason, as I told you in the figure, because at intersection points, so many possible directions of electric field lines at break point. Figure 7E. Yes, 7E, you can see one more time. At sudden breaks, we have multi-directions tangent. Not possible. Contradiction. Okay, student? Figures which is contradiction. Okay, now come to the property number 4. Uniform electric field can be represented by parallel lines. Before explaining this statement, I am going to again the figure number next, 7F. Look here. In 7F, what you are looking? Uniform electric field lines by parallel. Uniform electric field means, students, suppose there is a point anything, this. Same electric field E. Here, same electric field E. Same electric field E. Same electric field E. Any point you choose, student. Any point. All the points will have same electric field. How we can represent? By parallel lines. Okay, students? Uniform electric field can be represented by parallel lines. Now the statement would be very clear to you on the basis of this diagram. Okay, students? So I am going to the start of the heading. What I told you today, electric field lines, there are various examples why we study electric field lines and their most important properties. So keep in touch with these videos. You can connect these videos with the previous videos. The concept would be very clear to you. I'm going to finish this video number 7.